You've already gained some experience multiplying binomials or polynomials, but today we're going to look at what happens when you're multiplying, and you might be able to spot some patterns or what we could call special cases. We'll start off with this first one down here, and you would know that if you do these swooshes, it would represent either what you could call FOIL or double distribution, and I would get x squared minus 5x plus 5x minus 25 by following x times x is x squared, x times negative 5 is minus 5x, positive 5x, and negative 25. When you do that, you'll almost always have some like terms to put together, and here would be our final answer. Well, the pattern that you'll start noticing is when you have plus and minus the same number, these two like terms in the center will add to 0 or combine to 0 and disappear, and this will be your resulting answer. Do yourself a favor and copy these two onto a blank sheet of paper, pause the video, and see if you can come up with the multiplication reduced final answer that goes with these. When we look at all three of these, you'll definitely see the pattern. Hopefully you really have paused the video and tried these out. If you did, what I would have with this first one is the two like terms in the center going away, and I get x squared minus 49. The two like terms in the center combining to 0, and I get 9x squared minus 16. You'll start to notice a pattern that this is the square of the 7, this is the square of the 4, this is the square of the 5. We're going to use that information later on in this unit when we literally go backwards from a polynomial right here up into this form. By the way, just for review's sake, this x squared minus 49 is a binomial because there's two terms. It's degree 2 because its largest exponent is 2. The leading coefficient is 1 because there's secretly a 1 there. And the constant term is 49 because that's the term without a variable. We're going to cover one more pattern of multiplying. And before we do that, let's do a reminder. If you have 7 squared, if you felt like it, you could write that as 7 times 7. If you have negative 12 squared, you could write it like that. That means if you have x squared, you could write it as x times x. And then what we're getting to in these next problems, if you have x plus 4 squared, that really means x plus 4 times x plus 4. Anytime you have something squared, it's just multiplying by itself. That means if I'm asked to have x plus 4 squared, the very first thing I should do is write x plus 4 times x plus 4, because when something is squared, it means it's multiplied by itself. As soon as I make that move, now it's the same old multiplication we've been doing through many problems. I just follow those swooshes, and I would get x squared plus 4x plus 4x plus 16. Now, as opposed to the problems that we were just recently doing, in this case, the two terms in the middle are like terms, but they do not add to 0, so I get x squared plus 8x plus 16. My advice for you is take this problem, use this as a model, pause the video, and see if you can work that out on your own and compare it to my solution coming up here. Go ahead and do that, please. By using the top one as a model, you know that anytime something is squared, it's multiplied by itself. And once you have that, you're in the multiplication of two binomials. Follow your swooshes. We have two like terms in the center. They add to negative 48. And now I have my final answer, which is a trinomial of degree 2. Trinomial because 3 terms, degree 2 because the largest exponent is 2. For this last problem, we're going to look at a problem like this, and that probably looks a little different because we've been used to doing problems that look like this. When we have a problem like you see here in the purple, we would distribute the x to both terms, and then we would distribute the 4 to both terms. That's double distribution. Well, we're going to do the same thing up here. We're going to distribute the x to all three terms, just like we did up there, and then we're going to distribute the 4 to all three terms. So even though it might look a little different, we're going to follow the exact same thinking we did before. Now I'm going to carry out all that multiplication. The first swoosh, x times x to the second, I add my exponents and I get x to the third. And I'm going to keep doing now the second swoosh, now the third swoosh. Now I'm going to start down here. Now I do the 4 times the minus 2x and the 4 times the 7, and I get a very long polynomial. But if you look carefully in there, there's going to be some like terms. So for example, I see this x squared term and this x squared term. They're going to combine to be like terms. Same variable, same exponent. I have a 7x and a minus 8x. They're going to combine to be like terms. So when I get my final answer, I have x to the third because nothing's going to combine with that. These two to combine, a negative 2 and a positive 4 to be a positive 2x squared. A positive 7 and a minus 8 is a minus 1x. I don't have to write that 1. And then the 28 has no like terms. So there is my final answer. So when you get a problem like this, it's the same idea. Distribute the x, distribute the 4, and you're good to go. Before we're done here, allow me to state this warning. Students, for some reason, like to think that you can take the 2 and distribute it in when it's an exponent. That's not true. If you wrote x squared plus 25 by distributing that exponent, this is going to be wrong. When you get x plus 5 squared, you need to do this. Something squared is multiplied by itself. This is the proper procedure. No one in the entire world has ever said distributing an exponent is a legal thing, so be very careful with that tempting result or that tempting path.